Hello, dear authors. Good evening to all. Welcome to technical session 2D. I'm Jay Lalwani, moderator of this session. On behalf of Global Knowledge Research Foundation and Knowledge Chamber of Commerce and Industry, it is my great pleasure to welcome you to the 7th International Conference on ICT for Sustainable Development through Zoom. I hope you will enjoy a knowledgeable and interactive session throughout the day. There is a special note for the presenters. You will be given 8 minutes for presentation and 2 minutes for question and answer. In 7 minutes, I will raise a gentle reminder. Also, there is a special request for presenters. You all stay connected with us till the closing remarks. And you have any query, you can write it to me in chat box. Just before we get started, I would like to introduce you the chair, chair for the session, Professor Asta Parikh. Professor Asta Parikh is a senior assistant professor in the Department of Computer Science, IIS, Jaipur, since March 2010. Her research interests lie in the area of programming languages, data mining, cloud computing, and sentiment analysis. Welcome, ma'am.
Thank you, Jay.
Now, I would like to start with the papers. Our first presenter is Kiran Patil, and her paper title is Comprehensive Analysis Various Techniques of Data Leakage Detection in Different Domains.
Thank you, Jay. Shall I continue?
Yes, ma'am.
Yes, Kiran.
Okay. Is my screen visible?
Yes, it is visible.
Okay. So, starting from the abstract. So when sensitive, confidential, or protected data gets exposed to an untrustworthy environment, it is referred to as a data breach or data leak. So there could be several reasons for data breaches. Nowadays, patents, trademarks, and copyrights, these are the most widely used techniques which can be used to simplify or to make data leakage detection easier. So with the steep growth in information technology and its global reach, as well as the common citizens' ever increasing reliance on technology, data privacy and security has become a major source of concern for individuals all over the world, and it is becoming increasingly important. So when this important information goes to an unauthorized destination, it prompts the direct and indirect loss of a particular industry in terms of cost and time. So to solve these issues, there is a need for a system which can aid in data leakage detection. So as for introduction, we all know that data is critical. It is an important aspect as it contains sensitive information related to user privacy, like a user's name, their address, their PAN information, Aadhaar information, their finance information, including their credit card details, social privacy, such as their social security number, etc. So this data is a precious asset to companies and organizations for project and business insights. Nowadays, almost all of our data is becoming digital. And because of online sharing platforms, data privacy stands a major risk through hacking. So recently in January 2021, about 35 million user accounts data from JustPay was for sale on dark web. An unrecycled access key was used to steal details of around 35 million consumer accounts, including disguised card data and fingerprints from a server. In March 2021, around 45 lakh user data was leaked from known organization Air India, whereas Domino's also reported 18 crore users data breach in the May 2021. So a single corporation may have access to the personal information of millions of customers, which it must keep private in order to protect consumers' identities. So malicious third parties or hackers can steal this information for their own gain at the expense of ordinary people and businesses' private information. This data can be exposed in a variety of ways. It could be the result of a cyber attack designed to steal data, or it could also be an employee purposefully leaking or selling private data to a third party for their private gains. So our literature survey included research papers from various resources like IEEE, Elsewhere, and Springer, and it covered several domains. So these domains are guilty/fake agent, networking, cloud computing, Android machine learning, artificial intelligence, and deep learning. So the literature survey led us to the observation that the guilty/fake agent domain introduces techniques for detecting data leaks produced by malicious entities intentionally or unintentionally transmitting confidential or private data to unauthorized third parties. Networking domain included P2P file sharing and mobile ad hoc network. So using the P2P network, which is peer-to-peer network, which is fundamentally a direct link between computers, P2P file sharing allowed registered users to exchange and share files with fellow peers without the usage of networks. So the disadvantage over here was that it may allow internal personnel and customers' personal information to be leaked. Cloud computing included technologies such as techniques such as watermarking, use of active bundles, and other methods to detect data leakages in cloud and other web services. Android domain mainly focused on analyzing relationships of pre-installed applications and technologies that monitored Android apps in real time to detect privacy breaches. Machine learning, artificial intelligence, and deep learning mostly are about intrusion detection systems. This domain does not cover much about data leakage detection, but is useful for predicting various kinds of attacks like denial of service, remote to local, user to root, and probing for follow-up procedures. So there are several ways for leakage of data to happen. The data can be leaked by an insider or an employee of the information or by a third-party agent to whom the distributor shares data with, or by an external attack like hacking. So according to the troubles faced by an organization or a company, an organization can use appropriate methods, and they can be integrated with their systems, categorized by the various results and outputs of each technique. So these are the most suitable techniques that we found. Among the machine learning, artificial intelligence, and deep learning
Can you
papers.
come on the previous slide?
Yes, ma'am.
Previous slide 5, conclusion से पहले वाली slide कौन सी है? Literature survey, right?
Literature survey.
Okay, so literature survey, how many papers you have studied? Is basically what you have done. This is a review paper or what?
Yes, ma'am, it's a review paper.
So you must have added the literature part. आपको literature review add करना चाहिए था कि आपने कौन से papers पढ़े हैं, what they have done, and what are the limitations you have drawn. You have just covered the literature and then you have drawn the conclusion.
Actually, ma'am, we referred to a lot of papers. So every paper contained different techniques. So to track all of those different papers, disadvantages and problems. So it
So
actually
what you
wouldn't
have
fit
done, you have just, this is a review paper, right? But
Yes,
अगर
ma'am.
review paper है तो review literature review है ही नहीं. How can you decide कि ये आपने पढ़े थे और करा? हमको क्या पता आपने कितने papers पढ़े, क्या पढ़े? और आपने कोई conclusion भी ऐसा कुछ draw नहीं किया, आपने कुछ experiment भी नहीं किया है. So if you are doing a literature review paper, तो आपको एक table sort of बनानी चाहिए थी. And you have drawn the conclusion. Come to the conclusion. Next time onwards, please keep this in point.
Yes, ma'am, definitely.
Thank you so much for your presentation. The next presenter is Sajal Gupta, and his paper title is In Crypto, Decrypto. I think he's absent. Moving on, next presenter, Namisha Chauhan, and her paper title is Temperature Dependency of TGS 822 Model on ESPICE.
Namisha is present?
Yes, sir.
Okay, she can start.
Good evening, everyone. Yes,
Yes, you can start your presentation.
okay. Is my screen visible?
Yes.
Good evening, Kiran ma'am and Riyaz and everyone else. I'm Namisha Chauhan and I'm currently working as an assistant professor in Phonics Group of Institution 4D. And today I'm presenting my paper on temperature dependency of TGS 822 model on feedstock. So what I've done is we have used a gas sensor known as metal oxide sensor. Sorry, there is a little bit problem in sharing.
Your voice is not audible. थोड़ा सा आप तेज बोलिए.
Okay, ma'am. Okay, if it's not visible or not audible, I will increase my voice. Is my screen available on? So what I've used is the metal oxide gas sensor, which is known as MOS, which is used for detecting gases. I've used this sensor TGS 822 because it has high sensitivity in nature and is available at low cost. And it is widely used for detection of alcoholic gases as methanol and carbon monoxide and acetone. And it has a disadvantage that it lacks the selectivity and do have environmental effects on it. So my aim was to linearize the sensor's response characteristics which eliminates its dependency on the environmental parameters. So this is just the gist. And also, in addition, TGS 822 sensor belongs to Figaro Engineering, which is established by the Japanese company. The tool which I have used is P5 for the designing and development of the analog and digital logic circuits to simulate the behavior of the circuit in the real world. The model of TGS 822 is analyzed on MATLAB also, but here I have used P5 for this presentation and to show in this session of paper. The P5 simulator advantage is that it can be simulated by using very small representative database on P5. As you can see in MATLAB, you need to have a database which is quite bigger enough. Otherwise, it won't be able to analyze the data based on artificial neural net. The APM module helped us to study the temperature effect, which was analyzed with the DC-3. So what I've done is I've differentiated 5 gases: air, methane, carbon monoxide, ethanol, and acetone qualitatively and quantitatively. So in this table, we can see that we have a voltage like 1 volt. Then it will detect the respective gas as air. If the voltages are 2 volts, then it will detect the gas as methane. Similarly for ethanol, which is 5 volts, and acetone, 8 volts. So this is a model which is simulated on the P5, which has 5 different parameters, which are S represents selectivity of the gas or the detection of the gas, which kind of gas we are using. RF stands for relative humidity, which is approximately 65% of the concentration. T represents the temperature of the gas and C is the gas concentration. So all those parameters will be detected by the simulator by using ABM module and will be detected by using an electrical circuit which has a set voltage which is equal to 5 volts and a resistance which is equal to 10 kilo ohm. So to study this model, what we have done is we have taken two cases. For both the cases, the relative humidity is set to 65% and the gas concentration is kept as 300 ppm. The temperature effect is studied in two ways. In first case, along with all the parameters, RH and C temperature, RH and C, which stands for gas concentration, temperature is also fixed at 20 degrees Celsius. In the second case, what we have done is temperature is varied from minus 10 degrees Celsius to 40 degrees Celsius. And I've also, to differentiate, I have taken only three temperatures here, like minus 10 degrees Celsius, 15 degrees Celsius, and 40 degrees Celsius, and kept all the other parameters fixed. Here are the simulation results. By using parametric DC sweep analysis, you can see the variations in the results, because as you can see on plot number 2, that the input voltage over here is 1 volt and input voltage over here is 2 volts. As I've shown you the table before, for 1 volt, the gas is detected as air, and for voltage 2 volt, it will be detected as methane. So this is the input voltage, and we have shown its dependency on temperature. If the temperature is 20 degrees Celsius, the output plot will be a little bit deviated from the initial voltage. Like output will be deviated for air, and similarly for methane, it will vary. Next is what happened is for carbon monoxide, like input voltage is 3 volts. If 3 volt is available, then you can see that the gas is detected as carbon monoxide. But it shows a variation at 20 degrees Celsius. The output voltage is the curve will be deviate, which should be equal. So you can see that this sensor does have effect on its temperature conditions or environmental effect. Whatever relative humidity and all those parameters you see, it does show the result or does shows the variation. Similarly, for carbon monoxide, you can see for ethanol, you can see that. Next is acetone. For the last gas, acetone, you can also see that if 8 volt is available, then the temperature will be detected as such. And similarly, for this figure number 7, what has happened over here? In figure 6, the temperature is only set at 20 degrees Celsius. For figure 7, the temperature is varied to minus 10, 15, and 40 degrees Celsius for the same gas, acetone. So you can see that there is variations at different temperatures, that the gas will have a little bit of effect on its output. So you can see three graphs. It's not just one, but it's actually three different curves. A little bit deviation in acetone gas, but you can see a way more deviations in other gases. Like for the methane, you can see different at temperature minus 10, 15, and 40. It's very heavily differently. And also here also for CO gas, so carbon monoxide, you can see that it has variation. Similarly, for the other gases, you can see like last ethanol, and for air, these three differentiates, that one is at minus 10, 15, and 40. So for further, we can actually linearize it by using ABM or by changing the artificial neural network, by changing the number of hidden layers and that. But that is not presented in this. That portion is not presented in this presentation. I've done that. I've tried to linearize this by using a different module, but here I've shown the results. So what we initially aimed at was discriminating the They are qualitatively and quantitatively. So we have detected the gases as air, methane, carbon dioxide, carbon monoxide, ethanol, and acetone, and their behavior has been studied in this paper at 20 degrees Celsius and also at different temperatures like -10, 16, and 40. So these are my references. This was my paper, and most of the data has been shared from this paper only. And I've also presented two papers in other conferences where I present the that lab portion of this data session. So um, uh, this is my presentation. Thanks for listening. Any questions?
Thank you, Ramesha. Can you explain figure number 5, 4.5 to 3.5? This is 4.5. Yeah.
5. Okay, 4 and 5 years. Figure number 4 and 5. Hello.
Yes, this one.
Yes, ma'am.
Okay, you have done the comparison of this or what?
Yes, ma'am. Actually, it shows that we have different, gases at 3 volts and 5 volts. That you can actually detect which gases, is currently on the which is detected by the sensor. Like as in for 3 volts, it is carbon monoxide, and for 5 volts, it is ethanol. If the input gas is, uh, uh, if the input gas shows a voltage of 5 volts, then it's an ethanol. But it has, when it passes through or because of environmental factors, it does change its output, and it has, a deviation. Like it goes, it's not linear. It's not actually that linear, which is supposed to like that. Input and output voltage.
Okay, okay. Thank you.
Moving on, next presenter. Milan V. Kulkarni, and his paper title is Depression and Disclosure Behavior of via Social Media Using CNN. Milan, are you available? I think he is absent, ma'am. So we can call our next presenter, Ajmer Singh, and his paper title is Age Estimation from Face Images using CNN based on LBPS LBP.
Yes, Jay, am I audible?
Yes, you can start your presentation.
Okay, thank you. Thank you. Jay, sir, my screen is visible?
No, sir. You can type on share screen.
Yes, yes, I'm doing.
Yes, now visible.
Now it is visible. Thank you, sir. Good evening, all presenter and host. My name is Ajmer Singh, and I'm here to present my topic on age estimation from face images using CNN network based on the feature calculation of the LBP H and LBP feature. By one more author, Dr. Harpal Titi, is also. The first thing which I'm going to talk about is in the abstract of this paper, the point is the why age estimation is important, or what are the need of the biological characteristics. I mean, based on the biological character, if we can identify them clearly, we can differentiate human being on the basis of different classification. For that class, like age class, race class, gender, facial expression, we can also do. So it's a huge range of application from the face image. I have picked one that how we can estimate the age. What motivate me to do this research because based on the age estimation from phase images, we have many applications. Those applications include online surveys, computer interaction, public or private ID, renewal process, uh, where we need to identify the phase of the or the age of the subject from the phase. One example I can give, the renewal of the passport. We know the passport validity vary from 5 years to 10 years from country to country. And whenever we are going for the renewal of the passport, after 5 to 10 years, uh, the face need to identify the, from the face we need to identify the age. If we can identify it, we can easily do it. Second thing is, for the example of restriction of the video content, like we are doing the age restriction on the website content. If the capture image of the webcam image is belong to the age group which belong to the child or the under adult age, so some of the content may not be played. But if it is belong to the adult age group, the content can be played, and many other applications. In this paper, I use the neural network, deep neural network layers to tune them to adjust the hyperparameter so that I will get the age estimation result with the better improvement. I have done these age estimation result, calculate these age estimation result on two benchmark dataset. One is called as the FGNet dataset, and second is ADB dataset. The result which I got after doing this, I'm evaluating my result based on the two parameter. One is mean absolute error, and second is mean square error. So at the resultant, I got mean absolute error of 6.3 year and mean absolute error of 8.9 year using the LBPH features. Basic introduction I have told. Here I have shown the one subject images from the FGNet dataset at the different ages. So I have given these inputs to my dataset so that it can detect the age of the person based on the images. What methodology or what feature extraction I have used? The one type of feature I have extracted like LBP feature. LBP stand for local binary, and in this case, how we can calculate it? It is a image, and every image has its pixel. So what we are doing is we are comparing the main pixel with the neighborhood pixels, and if the neighborhood pixels is greater than the center pixel, or the neighborhood pixel is smaller than the center pixel. In case of smaller, we are assigning a 0, and in case of greater, we are assigning 1. Greater or equal, we are assigning 1. And then we are reading this content in the anti-clockwise direction, and that will become a 8-bit number. That we convert into decimal, and we can say it is our feature, one feature of belong to those features. How we can extract it, how we can calculate the local binary pattern histogram. In this case, I divided my entire images into the sum blocks, and then I have calculated the LBP feature. I have calculated these LBP feature for each and every block, for each and every pixel, and then we calculate their histogram. And in the last, what I have done is I just have appended the LBP features of one block with the LBP feature of the next block and so on. So that is the way how I am extracting the feature. After extracting the feature, I have stored those features on the data set, and I'm giving those features to my network. I have selected this 15-layer network, right? And in this case, I'm giving the sequence input, whatever the input I have created from the LBP and the local binary pattern histogram feature. So those sequence I'm giving here with the label also, age label also, for training purpose and for testing purpose. And then I have connected the fully connected layer here. After that, a dropout layer. Dropout layer is used to overcome the generally used as we used to deal with the overfitting problem of the network. So we can adjust the dropout percentage of the previous layer output, and we have repeated this process twice, and then weekly RALU layer we have used to convert the number into the positive numbers. And at the last, it is a kind of regression problem. Some of the authors have used this problem as is estimation as a classification problem, means they have classified their whole data into the set of group, like from 0 to 10 year one group, 10 to 20 year another group, 20 to 30 year another group, and so on. So that becomes the classified. But I consider this thing as a regression problem. So I have given the continue input, and I'm getting the continue variable. Here it is a distributed regression curve for both the data set which I have used. The distribution curve will give you the idea that what is the variety of the age features are available, or age images are available. In case of FGNet is a small data set, and it is around only 1,000 images it has, but it vary from 0 year to somewhere 70 years, but the images belong to the low age group are more, and the images belong to the high age group are less. Wherever my another data set, the HDB data set is a wide data set. It has more than 16,000 images, and in that images, it belongs to the age group category, and it have between 20 to 80 years maximum sufficient number of images, with the help of which we can train it and we can get the result. I have also gave some spreadsheet of these data set in the form of a table one. So the data set FGNet introduced in 2002, and they have considered 82 subjects, and from 82 subjects they have collected 1,002 images, and all those subjects have minimum 6 or maximum 8 images, and the age range of those subjects is 0 to 70, 69 or 70. So the maximum age left between this data set is 30 years. If one subject I have taken the image of a subject at 6 year age, so maybe I have taken his image at 35 or 36 year age. So not more than that much difference. But in the another data set, that is a wild data set, that is latest data set, it available in 2017. They consider more number of subject also to make it more wild. 570 subjects they have considered. Total 16,488 images they have considered. And for every subject, they are almost collected 29 images. Okay? And the age range is also wide, from 1 year to 101 year they consider. And the maximum time lapse which is available is 50 years. So that is few of the detail about the data set. Now I'm coming to the experiment result which I have got from this network. The first network which I have trained the same 9-layer network, and then I train it using the FGNet and tested it also using the FGNet. I have used the LBP feature to train and test the network, and I got the validation error somewhere, root mean square error. In this case, it is 10.5 something. It is not here, but it is table in the table. It is available. Same way, same kind of experiment. I have done the training of the FGNet same network using the LBP feature, the same image I have used here, just for the comparison with the local binary pattern histogram. So in case of local binary pattern FGNet, I got the error less than 10. It is coming somewhere 8.9 something. Reason is because the length of the LBP features are more. There are more number of LBP features, and also we have extracted the local segments also, local features also. In case of LBP, we are selecting the global feature of the images. So that is one of the reason also where my LBPH feature giving me little better result than the LBP feature. Second experiment which I have done on the ASDB network by using the same features. One, I have considered LBP, local binary pattern histogram, and second, I have used the LBPH, local binary pattern histogram. So in this case, what result I'm getting is, for the case of LBP, I'm getting a mean absolute error of somewhere 12.5 something. The reason here why I'm getting error more for the ASDB network, because as I have shown you, the ASDB network is more wider network. It has more number of subjects, it has more variety, more age, and that's why it's giving. FGNet is a kind of some of the basic data set for the age estimation task. But FGNet is the latest, so I'm evaluating my network on the latest data set also to get to know that how much more improvement is required in the coming days. Right? And then I tested the same network using the LBPH feature on the HDB network. So in this case, I got the mean absolute error approximately 11.7 something, but RMS error is approximately 14 point something. These are the results. I have summarized all my result of the figures in form of a table for the easy comparison. So what I'm getting good result, I'm getting a better result on the FGNet with the LBP feature. So what it indicating is LBP feature is more strong because it has more values. So network is able to classify in a better way. But FGNet give better result because FGNet is not that much dense network. It has less number of images, less number of variety, but ASDB network need to improve still. If I end with the conclusion, in case of age estimation is again one of the main requirement in many applications, as we have discussed, like age group advertisement. If we need to do the advertisement based on the age group, so we can use this application. We need to identify the individual based on the age group. We can use this. We can classify the human in form of child, adult, or old. We can use this application. So this in this paper we have designed a system which can be implemented in form of application on a system with the help of a camera, real camera. So that can be implemented. So we design system, we validate and test that system on the two network, FGNet and HDB. So our work we have analyzed, we evaluate our work by using two parameters. One is ME, mean absolute error, and second is RMES, root mean square error. So as a result, conclusion is we are getting better mean absolute error in case of FGNet and local binary pattern histogram feature. So this comparison, this thing I have already covered, that why we are getting better result in case of FGNet, but why not in case of HDB. So still I'm extending my work, still I'm doing my work to get the better result for the HDB network also. This is my work. Thank you. Any questions?
Thank you. Very nice presentation.
Thank you, ma'am.
So what is the minimum error which you have calculated?
But in this case, I have calculated the 6.3 mean absolute error in a year. Year means, let's suppose I have given the input as a age and the subject age is 15 years. So my system may give me an error of 6 years, or it will display the student age or the person is 20 years. So that is the error. Still, this error is big. Still, there is a lot of scope of improvement. So that is also my future task. I'm also enhancing the networks that how we can get more reduced error. That is the main.
Okay. Thank you.
Thank you, ma'am.
Thank you so much for your presentation.
Thank you, sir. Thank you, sir.
Our next presenter is Sujoy Chatterjee, and his paper title is an AHP proxy integrated model for better ranking for concentrated crowd opinions. You may start your presentation.
Thank you, sir. Good afternoon. Good afternoon, everyone. So now I'll be presenting. I will share the screen. Hope it is visible, right?
Yes.
Okay.
Yes, you can start.
Thank you. Actually, it should be in full screen mode, but still a few minutes back it was working. Okay. So the paper title is an HP Propsys integrated model for beta ranking in constraint crowd opinions. So this is the basic overview of my slides. First of all, I will discuss basic introduction of crowd judgment analysis model, and then we'll discuss this constraint judgment and how we can find the better ranking from crowd judgment model. So basically, we proposed a model, and thereafter some experimental result followed by that conclusions. So what is this judgment analysis? So judgment analysis is a general way of learning about human decision from multiple opinion. So basically, suppose someone has some questions like showing my son Disney Aladdin, make him to join ISIS. So how will get his answer? He does not know the answer. So he can outsource this problem to crowd, that means human beings in social network or somewhere else, and he can get the feedback from them. Now the problem is in crowdsourcing, without investing so much money, you can solve a larger problem, and you can distribute the work to multiple people and get the feedback from them to speed up the process with less money and less effort. So if there are three choices like a skip, yes, and no, so in traditional crowd judgment model, there are three options like skip, yes, and no, and people can do their voting over there. But now the problem comes here. In traditional model, we can use that majority voting. If that decision maker wants to find the final answer, we can use that majority voting. Now, what is going on in this response matrix? This is the traditional one where there are some crowd worker or annotator, we can say annotator also, and there are some questions. We have some question and we want to make the decision based on that questions. So suppose there are some options like yes, no, unsure, I can't tell, skip. These are the different options and these are defined. Now, if I want to find the answer from multiple opinion, I mean that annotators, then what should be the final answer? So for question one, we can receive, suppose these are the 5 annotators and 4 responses we received. So according to majority voting, that yes will be the final answer. So if I want to, or decision maker want to make the final judgment, in that case, he can do simple majority voting. So in this right hand side, we can see this is a judgment matrix where that row wise there are question and column wise the options are. So here there are 5 options like yes, no, unsure, I can't tell, skip. So here there are 5 options and this denotes the weight. So I am giving an example that for this example here in response matrix, if I do some kind of majority voting, that creates a problem to make the aggregation, because in social network, in crowdsourced market, that people cannot be reliable. Someone without knowing the answer, he can give some wrong answer. So that's why majority voting does not work well. So in that case, there are different methods available in crowdsourcing market to find the final decision from multiple opinions. But in this problem, we are considering some constraint opinion where there are some like real life applications like smart city planning or facility location where this type of defined option set is not available. I mean, yes, no, skip. So this kind of option sets are not available over there. Rather, some coordinates are given. For example, if suppose one organization wants to install 3 facilities or 3 ATM counters in a locality. So in that case, what should be the answer? So the solution should be like some 2D coordinates, and there should be some constraint over there, because if you put two adjacent ATM counters inside, I mean that in a local city, I mean that in a city or adjacent we can put over there. So that will not be good because that many people will not be served by this planning. So that's why we need a constraint so that some distance should be maintained between these two adjacent ATM counters. So that's why we have introduced one model that is called constraint judgment analysis model. So we have introduced this constraint judgment analysis model long back, but still there are some problems in constraint judgment analysis, and the limited research has been done on this area. So what happened in normal case, suppose that question one, this is the response matrix for normal scenario, and this is the response matrix for constraint scenario. So here these opinions are like 10, 20. So suppose this is a question one. Here we can see on the right hand side, these are the three coordinates for three ATM counters. And there are some relationship because these two ATM counters should have some distance. So this is a constant. So see here in left side, in this response matrix, we can, for understanding this final judgment, we can apply this majority voting or different traditional algorithm to find the weight of the crowd worker. How much he is deviating from the majority, how much he is deviating from the mean opinion. So these are the different procedure to communicate, I mean to find the weight. Because if we consider this majority voting, that means you are trying to consider this all these annotators as equal expert. That is not possible in real life scenario. So that's why we can apply majority voting or some kind of weighted voting over there, but this kind of things cannot happen here. We can't apply this majority voting. See, these are the different components in a particular solution. This is one solution, but there are different components. So that's why we can't rely on that majority voting, because there is a hard chance. I mean, this is very difficult to find the same opinion repeatedly. Here, some opinions can be repeated, and based on that, we can do some kind of majority voting. But these opinions are discrete. So that's why we can't apply any kind of majority voting. So different method we need to think over. But here, another major problem is how to find the better ranking from this opinion. We can apply different traditional ranking method, but this ranking method is difficult to apply in this constraint case because we don't know what should be the objective. So here we need to define the objective first, and we apply that AHP Topsys based integrated model. And before that, we need to find the optimal solution that will be considered as the close solution among all of this crowd worker solution. So that's why. So for this is the basic challenges that we have already discussed. So here we can see, as it is not known to us that which are the possible options, that is yes, no, skip, unsure, that kind of defined option set is not available. Only some starting coordinate or ending coordinate is given. So therefore it is very hard to find the posterior distribution of all these possible options. And if multiple objectives exist, then it will be very difficult to understand which criteria should be weighted or which criteria should not be weighted. So based on that, we have prepared this, some solutions. So first of all, this is our problem formulation. Suppose these are the opinions. There are some questions Q1, Q2, QT, and these are the annotator set, that is crowd worker set A1, A2, AN. And for each particular crowd worker, we are getting this kind of opinion. This is for first component, this is for second component, this is for third component, and then we have to aggregate this answer to find the best possible decision or judgment. So now this purpose of this article is to create the better ranking from all of this constraint crowd opinion. So see, this is the opinion here. This is for first component, this is for second component, this is for third component. Here there are some Euclidean distance, and this should be satisfied greater than T. This T means threshold. So while crowd workers are giving their opinion, they are satisfying their constraint. They know that I should keep the 20 distance. But when you are aggregating, first of all, we can't aggregate because that there is a less chance to find the repetition over there because these opinions are discrete. Second, if you even get some kind of repetition, then if you apply this majority voting component wise, even it cannot guarantee that constant satisfaction process. So how I can satisfy this constraint and how we can get the optimal solution, this is our objective. Next, what we do, so here, first of all, the first challenge is relabeling of this crowd worker. That means it is not defined that some coordinate will be for first component. This is for second ATM counter. Component means ATM counter. There are 3 ATM counters. So for example, someone can treat this is the first ATM counter, this is for second, and this is for third. But someone can put this as a second, same coordinate, but just he has suppelled, suppose. So in that case, 22, 33, 10, 20, and 42, 30. This will be his solution. So in that case, relabeling of this crowd worker solution is very much needed. So for this example, that relabeling of this crowd worker, so
Please
I will show
explain this table once again.
this one. So this is
Yes.
this is for first counter, this is for second ATM counter, this is for third ATM counter. Suppose someone has put this as 42, 30 as first and 10, 20 as last, but we can't tell these are the 2 different solutions. These are the basically 2 same solutions. So we need to find the standardization among these crowd worker solutions before proceeding next. Is it fine?
Yeah. You can
Okay,
proceed.
fine. Thank you. Yeah. So I'll show you one example based on that. For example, this is like choose the objective function. This is very important. So in our case, the objective function is coverage of this. Coverage of this area or area coverage enclosed by these 3 points. So here, if we serve maximum people with these 3 points, that will be better. So better is maximize this coverage. Second one is if the distance from this crowd worker solution from all other solutions. So we have to calculate the mean solution. And we need to find the deviation of this solution from this mean solution. So if it deviates too much, then we can't treat it as a good crowd worker solutions. Maybe he does not know the actual answer, just he put some coverage, that maximize the coverage, but we have larger deviation. So in that case, that solution will not be treated as the good solutions. And then we apply multi-objective genetic algorithm to find the better optimal solution, because there is a trade-off. It has been seen in the data set when we have experimented this, we have applied this algorithm. It has been seen that from crowd worker solution, if you want to maximize this coverage, always the deviation will be higher. So how much deviation we should allow? So that's why it is very important that how much weight we should put on this first objective and second objective. Is of course, we need to put the better coverage. We need to consider highest coverage. If someone, some solution has 0 coverage, but less deviation, we can't treat as a good solution because it will not serve our purpose. So that's why we put, we applied this multi-objective genetic algorithm based approach. And after that, we got an optimal solution. So please remember, this is a solution where this kind of solution will generate. So this kind of solution will generate from this multi-objective optimization. After that, we will derive the features. So derive the features means this area coverage enclosed by these points, right? And the deviation from this mean. So that should be calculated. So derived feature will compute. After that, what we have done, we use this AHP Topsys based model. So I'm not discussing this whole AHP Topsys model. So here basically some positive decision matrix will be done. And after that, we should calculate this weight based on some rules, Satis rules. So here we have kept this pair of Satis scale. So here we can put, there are 2 objectives. So I can put 1 and 3. So one means equally weighted. That these are considered as equal. Then 3, that is moderately. So we can put 3 as coverage and 1 for standard deviation or that mean. And next we can do 5 as a coverage. That's weight for this coverage. And second objective function is minimization of this second objective function, that is deviation from this mean. So we have considered these both things, 1 and 3, and try to find that what will be the possible ranking, and so that we can make the choice. We can make the choice, and decision maker can make the choice from different answers. So here, after that, basically we applied this before this. You see here, before applying this AHP Topsys, we have to apply this multi-objective genetic algorithm to find the optimal solution, and then we derive the weight, and this weight will be based on this AHP Topsys model. So finally, we will find the solution and get the deviation and coverage, and based on that, we will get the final ranking. So this is the encoding scheme of one solution, that is chromosome. So here in multi-objective optimization, chromosome will be treated as the one solution. So here this is the solution. This is for fast ATM counter. So fast location, this is fast coordinate. that is X coordinate. This is second coordinate, that is Y coordinate. And this is for second location. This is for kth location this way. So now these are, I have already discussed this part. This one approach is their PGM based approach. So there are some approach that is available for different kind of crowdsourced opinion to find the weight of this crowd worker. But this kind of approach will not work here because we don't have this defined option set. We have to define the option set. So next, this is our data set preparation. Actually, I did work in my postdoc. I did work in UNIST, that is Ulsan National Institute of Technology in South Korea. So there we have gathered this data. So we made a survey for this 3 ATM counters. So this is the university where some diverse type of demographic nature exists. So this means some kind of forest, some ponds, some other even space are there, field, grounds, everything is there. But I tried to identify what should be the best possible locations for students as well as staff to find the best possible ATM counters. So that's why we collected this opinion from them. And finally, I tried to identify which should be the best possible answer. So we tried to apply this model with this crowd worker solution. So basically 24 crowd worker response we received, but among them some persons have provided options for only one ATM counter, so that is not considered as the feasible solutions, and so we had to remove this. So this is the XY coordinate. So we provided that grid map, and then we, after taking the permission from university authority, we posted it in different places in social media as well as university lift, canteen, classroom, outside of this classroom. So there we have put it, and in display board actually. And then finally we got that response, and these are the different results. So what we have done here, we see these are the derived feature. This first one is coverage, second one is the deviation from this mean. So these are the 20 crowd workers, these are the response. And after applying this proposed solution, we got the different ranking. So here, one thing we can notice that, see, crowd worker 13, he has given one solution that derived feature is like something, coverage is 0, but deviation is also less. But according to the general Topsis model, where both of them are weighted as equal, like 1, 1. So in that case, we can't tell this is a good solution because this coverage is less, although the deviation is less, but coverage is 0. And we can't, because this will not serve any people there. So that's why it is like the ranking is 4 here. But you see, it should be less, the ranking should be higher. So if we use this kind of Topsis model, IHP Topsis based model, we see that 14 is the ranking here. So here, if we again, we see this is the highest coverage, 1.1375. This is the coverage, and this is the 0.0519, sorry, 0.551. So this is the deviation from mean. So you see here the coverage is not highest. So the highest, so it is basically 2, but although this coverage is so good, here it is 5. So this kind of approach, like how I can put the weight and different combinations of weight. So you see here this coverage is like 0.83 and 0.16. For this MOGA, that is for multi-objective genetic algorithm, we got this weight like 1 and 0.3668. And here in AHP based Topsis model, we verified, we varied this weight with this Satis rule, like 1, 3, and 5. So based on that, we have kept different weights there, and we made the possible solutions, possible ranking over there. So this is the way how I can solve this kind of ranking for constraint opinion. After that, you can give the weight and find the better solution from these crowd workers. So these are the different results. And as in conclusion, actually in our model, we have prepared this data set. But here, one thing we can do, this is a kind of independent opinion from this crowd worker. We received the independent opinion from the crowd worker, but we are trying to find that model that will contain the dependent opinion from the crowd worker. So that thing will be more difficult. So we are trying to think in this direction. Another thing here, we have collected 2 choices, like objective 1, that is of coverage, and the second objective is deviation from mean. So if there are multiple choices, so in that case, how these things will be, we'll solve this problem. That is another proposed direction. So we'll try to find in this direction. These are the different references. So we have extended this model based on this previous model. And so a TOPSIS inspired ranking using constraint crowd opinion for urban planning. And before that, actually in this TOPSIS model, no weight mechanism was used. But here we are providing different kind of weighting mechanism. And then the next work is to extend this work in this direction of dependent judgment model. Thank you so much.
Thank you.
Thank you, ma'am.
Moving on, next presenter, Priya Gokhale, and his paper title is Towards Managing Technology Challenges for Agriculture Technology Startups.
Yes, sir. So can I start?
Yes, you can start your presentation.
Okay. Yeah. So is the screen visible?
Yes, you can start.
Just give me a second. I'll go to the full screen and then start.
Oh.
Sorry for the slide. Yeah. So with your permission, can I start?
Yes, you can start.
Yes. Thank you so much, sir. So good evening, everyone. I'm Dr. Prayag Gokhale, and on behalf of my team, which consists of Dr. Praveen Kulkarni, Dr. Appasab LV, Dr. Lakshmi Narayan, and Dr. Basuraj Tigdi, I'm going to present our paper on towards managing technology challenges for agriculture technology startups. So just to give you a brief introduction about what this particular paper means is basically, as we say, agriculture is the backbone of the Indian economy, okay, where a lot of people still depend on agriculture as their livelihood. Okay, a lot of technologies are evolving in this particular sector, and lots of investment is happening in this particular sector to make agriculture more developed or more modernized. We are not concentrating on how to modernize agriculture, but we are concentrating on how these startups which are entering into the field of agriculture, they are providing solutions to agriculture. What are the various technological challenges these startups are facing? Okay, so basically, to introduce, agriculture has supported the growth of human civilization from its inception. Agriculture is one of the most important sectors for the growth of economy across the globe. In fact, then agriculture, though, as we say that it's one of the most important sector, but still the practices that are followed in agriculture are still traditional and primitive. So nowadays we find a lot of technology like machine learning, Internet of Things, big data, cloud computing have supported considerably in the growth of agriculture. So we find drones, we find the machine learning algorithms which can detect diseases or kind of the crop, health of the crop, etc., to help the farmers. Okay, so this is what is happening. This is how technology is evolving in the field of agriculture. But technology in manufacturing is also evolving at the rapid pace, okay, and has provided an opportunity to increase the productivity of manufacturing in the agricultural startup industry, which is our basic focus, agricultural startup industry. So we are going to basically speak about how these agriculture startup industries are working and what are the various challenges that these agriculture startup industries are facing. So agriculture, so artificial intelligence and machine learning along with IoT is one of the most powerful tools that we found, which helps agriculture startup industries for improving their production efficiency and enhancing customer satisfaction. So what we have done is we have identified these key challenges through various literatures that we have studied, and through our own surveys, we found that these are some of the challenges that are faced by most of the startup industries, like device applied in the technology, the various devices that we apply. Suppose we are talking about technologies like artificial intelligence or machine learning, or else IoT for that matter. There are lots of devices which are used. Okay, so application of this device or this technology is one of the challenge, like exactly what are the various devices, how do they work, and all those things, that is becoming a problem. Second thing is the quality of data. Now, when we are talking about artificial intelligence or machine learning, the entire system or the spectrum of these technologies work on the data which is available. And if we get quality data, then only it works well. Okay, otherwise that that we thought will be faced. And last one is the scalability of this technology. Like, is it worth, like, will it be really possible to scale it at a large scale and make it as a commercial business and all that? So these are the challenges that we identified from various literatures that we studied. Okay, and then we went on to survey various startups to understand what is important, what are the major challenges out of these 5 that we have listed, what are the major challenges that they are facing and how do they resolve it. Okay, so the most prominent technology among the agriculture startup is the application of IoT. This has been used at a very large scale in most of the manufacturing industries, and now agriculture startups or agri-tech startups are not an exception to it. So they are also using IoT at a large scale. These startups include this technology to provide sustainable solutions to the challenges in the sector, and despite the capability to provide sustainable solutions to agriculture sector, these startups face challenges which regard to device, data, network, application, and system. So let me just go on to the various objectives that we have tried to address in this particular paper. Okay, the objective 1 is determining the technology challenges faced by agriculture technology startups. Evaluate the relative importance of each technology, for which we have used TOPSIS, and the fuzzy logic is used to identify, since it's the technology which is not so normal or which doesn't go into a particular standard as such. So fuzzy logic is one thing that we thought was very important to be used, and we have used TOPSIS also to evaluate which are the various challenges, or what are the major challenges. So to rank them in an order, we have used that, and then determine the influence of the location of agriculture technology startups in resolving these challenges. Okay, so literature review, basically we have done literature. I have not purposely put the various literatures that I have studied in the references. I have given the references but not the literature review here. But the literatures that we have done is majorly on these 3 points, that is, how did the technology in agriculture grow, that is the growth of technology in agriculture. Then we have also collected a lot of literature and studied a lot of literature on startups in agriculture, agri-tech industry, which is our major samples for the study, and the challenges that are faced by startups in implementing technology in agriculture sector of India. So these are the 3 sectors or the 3 premises where we have studied the literature, and then we have come up with this particular paper along with the surveys that we have done. So basically, these are some of the criterias that we said that I've already told you. The criterias are device applied in technology, quality of data, network support, as well as application in real time, and system for scalability. We have also identified the sub criterias under each criteria. That is, under device applied in technology, we can talk about high cost, variable weather conditions, wireless device has limited battery life, WSN has higher energy consumption and higher cost of batteries. Similarly, we have the sub criteria for quality of data, which includes challenges to user, high quality data, lack of availability to users, high quality data, privacy of data, integrity of the data, and interpretability of the data. Okay. Similarly, for network, we have unstable connectivity, low transmission, propaganda uses, etc. Okay. As well as for application in real time, we have challenge to receive real-time data, lack of context awareness, cyber security challenge, modularity, reliability, etc. Whereas when it comes to systems for scalability, the sub-criteria that we have considered is scalability of the system, flexibility of the system, robustness of the system, affordability of the system, and continuous improvement in the system which is required. Okay, so on the basis of these major criteria and the sub-criteria, we've come up with the results. Before that, let us understand what is our sample and how we have done this survey. Okay, basically, this is the profile of the respondents. Like we have considered the startups in Karnataka, where we have studied the industries which range from 0 to 1 years, 1 to 3 years, and 3 to 5 years. Okay, then the founders' experience. Okay, which is 5 to 10, 10 to 11, and so on. The customer category is basically technology service and predictive services. And a designation of the respondents who have responded is either they are the founders or they are the venture capitalists whom we have basically met. We have surveyed basically. So as per them, as per the survey which is conducted, this was the results of our analysis. Okay, so basically, if you see the criteria as such, okay, the various criteria are mentioned. Then then their weightages are mentioned. So if you go ahead with, if you see the weightages given, okay, system for scalability is one of the major. Sorry, the system for scalability of technology is one of the highly weighted criteria, which is considered as more important or more challenging to scale your operations to a commercial level. And next one, and the most important, was the quality of the data. Okay, like we said, the reliability, etc., of the data. So that was one major challenge that most of the founders and the venture capitalists that I spoke about in the previous slide felt these are the most important criteria, or these are the most important challenges that we are facing. So accordingly, if you see, if you take the sub criteria for that matter, okay, the ranking given is majorly, first rank is for D3. So I'll just please pardon me, I'll just go to the previous slide. So D3 basically talks about cyber security challenges. That is the major challenge that the people thought was important. Coming to the next one was your scalability. In scalability, E4 was basically talks about the affordability of the system, which is very important. So these are some of the, this is how the analysis has been done using the criteria as well as the sub criteria, so that the industries who want to enter into this particular sector of agri-tech understand what are the real challenges that that are facing, and how help them to overcome these challenges. Plus, we have also done the Topsys analysis, where we have ranked the various alternatives that we had, that is agriculture startups, reduce the cost of agriculture through.
Please explain this quality of code ranking. You have
Sorry?
given 2, 4 ranking now. Quality of code data. Yeah, quality of data.
Quality of data is basically, ma'am, the data that we collect, is it really reliable? Okay, I'll just go back to tell you. See, quality of data is judged on the basis of these sub criteria. That is, higher quality of data, or lack of availability. Sometimes it's privacy of data or integrity of the data, whether the data is collected in a proper manner or no, and whether the data which is collected is, can we really interpret the data. So all these criteria help us in understanding how is the quality of the data which is collected through various devices that we are planning to implement in the agricultural fields.
Okay.
Yeah. So, and coming to the next one, the alternatives that we have suggested, agriculture startups reduce the cost of agriculture through this technology. Okay. Then agriculture startups create aggressive awareness of this technology, and agriculture startups conduct training programs on the use of this technology. So basically, to promote their technology, how can the agriculture startup promote their technologies to the farmers, basically? So the most important thing was that we found from the survey was that there is lack of awareness amongst the agriculturists about the various technologies that are available. So the most important thing that the agriculture startups should look at is to create awareness first. So that is the first thing. Then once the awareness is created, the farmers know about, yes, these are the technologies which are available, which will help them to increase their productivity. Then next step would be training program. Okay, training them on various technologies as to how to use those technologies is very important. And last and the most important, or let's say that is also important in terms of a farmer, when you look at a farmer, is the cost of that technology. Because we cannot, as an agriculture startup, I can develop n number of technologies, but how affordable is that technology to the farmer is also very important. So these are the 3 alternatives that we found out, and we have ranked them accordingly. So to discuss and conclude, the key challenges of implementation of AI and ML in agriculture startup units is the network support. Okay, that part was considered in the analysis itself. So network support is influenced by factors like unstable connectivity, low transmission. So again, I'm talking about the network issues there, propagations, then latency issues, etc. And finally, the study results indicate that AI, ML, and sorry, I did not consider IoT there, is a powerful tool for agriculture startup industry for improving production efficiency and enhancing customer satisfaction. So this is the conclusion of the entire paper. These are the various references that we have, the few references that I felt I'll just put it on the slide. These are the various references that that we have used during the research. Okay, that's it. Thank you.
Thank you.
Thank you. Thank you so much.
All the presentations are done. I sincerely thank our authors for their excellent presentation. And all the presenters would be part of the international conference. I hope this session was informative enough. We on behalf of whole team, thank you for support this version and previous 6th version of this conference. And very happy to have you in 8th version in 2023. All the participants would be getting their digital certificate in through email within 2 to 3 working days. Further, all the papers are already forwarded to the Stinger. The publication live within 5 to 6 months. Kindly cooperate with the team of ICT4SD 2022. And now I would like to thank our session chair. Ma'am, there's a token of appreciation on behalf of Team ICT4SD and Global Knowledge Foundation. Thank you, ma'am, for your valuable presence.
Thank you for inviting me for the conference, and I take this opportunity to convey my best wishes for an effective, successful, and productive conference. Thank you, Jim.
Thank you so much, ma'am. I request all the participants to turn on their camera for the quick snapshot for the virtual conference. Thank you so much, all. Stay safe, take care. Thank you.
Thank you, Jay. Thank you so much.